Sometimes the smallest things can be one of the biggest headaches. During the Apollo missions of 1969 to 72, the tiny particles of lunar dust turned out to be a major issue. Described as being as fine as talc but as rough as sandpaper, it also had properties that made it dangerous for both men and machines, and has been cited as a bigger problem for future astronauts than radiation by some scientists. The lunar surface is covered in a thin layer of dust which has been created by the bombardment of meteorites and micrometeorites over millions of years. These smash into the moon's surface at speeds of up to 12 miles or 20 kilometers per second, heating up and pulverizing rocks and dirt which contain silica and metals such as iron. Some of the dust is melted in the extreme heat of the impacts, which creates tiny glass beads as the silica melts and then cools and falls back to the surface. This continual smashing shatters the silica and other minerals to produce finer and finer grains of dust. But because there is no weathering on the moon like there is here on Earth, the edges of these tiny shards, which are not only very hard, they also remain very sharp and jagged, which makes it incredibly abrasive and potentially damaging to anything it sticks to. NASA had an idea about the dust before the manned moon missions from the previous Surveyor landers, but it quickly became apparent that once men were there, the dust was going to be far more of a problem than they first thought. In fact, before the mission started, some scientists thought that because the dust had not been in contact with oxygen, that it may spontaneously combust if exposed to air. Before the departure of Apollo 11 from the moon, Buzz Aldrin and Neil Armstrong had to carry out a rather ad hoc experiment to see if the dust was safe to bring back into the lunar lander in an air environment. They got a grab sample of dust and went back to the lander. They placed some of it on the engine cover of the ascent module. They then closed the hatch and repressurized the cabin, whilst looking out to see if the dust started to smoke. Luckily, it didn't, and they got on with the departure. Aldrin said later that if it had, they would stop the pressurization, open the hatch and thrown it out as quickly as possible. We've seen the astronauts bouncing around on the moon's surface and getting covered in lunar dust. They also found that the dust sticks to anything it comes into contact with, from the sun visors on the helmets to gauges, dials, tools, and more importantly things like seals on the spacesuits and containers for bringing back the rock samples. The dust is electrically charged by the bombardment of charged particles from the sun, and this is what makes it stick to anything it lands on. During Apollo 17, crew members Harrison Jack Schmitt and Gene Cernan had reported that the dust was making it difficult for them to move their arms around during the moonwalks because it had got into the joints of their spacesuits. It also scratched the gold visors on the helmets to such an extent when they tried to wipe it off that it made it difficult to see, a bit like trying to clean glass with sandpaper. The same applied to cameras and other optical surfaces which had to be cleaned with a small camera cleaning brush to avoid damage. It also damaged the seals between the gloves and the spacesuit locking rings so that they started to slowly leak air in the vacuum on the moon's surface. Just how abrasive the dust is was revealed when it wore through almost 3 layers of a Kevlar-like material on Schmidt's moon boots as he made his way around the lunar surface. The Apollo missions brought back 382 kilograms of rock samples. These were placed into sealed containers to keep in the low-pressure atmosphere of the moon in with the samples. However, when they got back to Earth, it was found that every sample box had leaked air in from the cabin because the dust had damaged the seals on the containers. There was also no way to isolate the crew from the dust in the lander cabin either. There were no airlocks and nowhere to change out of their suits other than in the cabin. When the crews returned to the lander and repressurized the cabin, on every mission they noticed that some of the dust became airborne and floated around the cabin, not only coating the inside of the craft, but they also breathed it in as well. They said that it had the smell of spent gunpowder or wet ashes in a fire. And after the mission, Cernan said that it took about 3 months for the embedded dust to grow out from under his fingernails. On Apollo 17, Schmitt said that he felt congested and complained of lunar dust hay fever, but the symptoms disappeared the next day. It's because of this that the crews were put into quarantine when they first returned to Earth, because no one knew if there were any biological threats on the moon or in the dust. Although by Apollo 12 this had been discontinued as it had been confirmed from examination on Earth, but it posed no bacterial or viral risks. Although the dust is mostly silica and non-poisonous, the extremely small size of the particles posed a similar problem to that which had been discovered when miners and tunnellers on Earth had become ill and died of silicosis years after dry drilling. Silicosis is where the tiny dust particles are so small that it gets into the very deepest parts of the lungs and cannot be coughed out. The white blood cells of the immune system cluster around the particles, and the victim eventually dies as the lungs become more and more ineffective. Another problem with the dust and the lack of a lunar atmosphere also came to light again with the Apollo 12 mission. When they landed, it was about 180 metres or 600 feet from an earlier Surveyor 3 lander, which had been there for a couple of years. The Apollo 12 astronauts detached the camera and mechanical scoop from the Surveyor lander for return to Earth. Whilst doing this, they noticed that the structure of the lander had been darkened by the cosmic radiation over time, but some areas had effectively been sandblasted clean by the dust blown out by the rocket engine exhaust from Apollo 12 as it landed. This was confirmed when the camera and mechanical scoop were examined back on Earth, as they had been damaged by the high-speed particles of dust. It's now believed that some of the smallest particles of dust that were ejected by the blast from the engine, which can also be seen from the landing footage, could have been blown halfway around the moon due to the lack of atmospheric resistance, although most of it would have only gone as far as high-sided craters or nearby mountain ranges before it was stopped. It's estimated that the lunar soil, or regolith, and the dust had been travelling at about 1,300 feet or 400 metres per second, which is as fast as a bullet from a gun. This means in future, craft landing near other structures, buildings or even astronauts could cause damage to them by this sandblasting effect, even at some distance away. For future manned journeys to the moon, NASA and scientists around the world have been working on ways to control the dust using technologies like film coatings that the dust won't stick to and shaking the dust off with an electric charge. As the dust particles contain tiny pieces of nanophase iron or pure iron, and this is affected by a magnetic field, this could be used to extract the dust from the air in filtration systems. So if you thought that the dust in your house was a pain, just be thankful that it's not lunar dust. Anyways, I hope you found this little piece interesting and informative, and if you did, then please subscribe, rate and share, and also check out some of our other videos which you may be interested in. So until the next time, it's goodbye from me.